A happy evening to you all and welcome you all to the fifth day of SSERD outreach program. Let me first begin the session by congratulating you all on on the amazing way you have done all your assignments and homework. You guys have put in so much soul and effort into all the homeworks that we are overwhelmed with the response. Timo the alien loved all the letters that were sent out to her, and she's looking in for making new friends. You all learned about the universe and how celestial bodies form and the kind of technologies we use to go out into space. Today, I'll get you back to Earth. Well, I won't land you back on the ground, but you'll still be able to fly today. Because today's session will be on how do aeroplanes fly. I, as a kid, always wondered. I had this question in mind. I mean, I'm so light, I'm much lighter than an aircraft. Why can't I fly? Airplanes are so heavy, but still they can soar up and high. They don't even have to flap their wings. I used to think and I tried finding answers to these questions as a kid, but I never could come up with my own answers. I took the help of others, I took the help of elders to find out answers as to how aeroplanes fly. Today, me and Aakansha, I'm Thejas, and my colleague Aakansha will be sharing you about how aeroplanes fly in the sky. Well, you're looking at a picture of an aeroplane. Then there is a bird. There's a kid who's flying a kite. What do you think is common in all these three things? Hmm, let me think. I guess you all got it right. They all can fly. Come to think about it, I mean, if they all can fly together, it means that there must be something in common which enables them all to fly. Today, we'll be exploring the science of flight as to how birds fly, how a kite flies, and how an aircraft flies too. Without delaying further, before we learn the science of flight, we must know about the history of how humans tried to create flying machines. Once we know about the history and the dreams that humans had to create the flying machines, we'll be able to understand the principles of how a flying machine, that is an aeroplane, works. So quickly, I would like to invite Aakansha on the screen to narrate us the wonderful story of how we created metal birds that fly up in the sky. Aakansha, the screen is yours.
Hey Tejas, hi, I'm Aakansha and I'm from SSERD. Now you must be thinking that many years ago, people used to think, whoa, how's this bird can fly by flapping our hands in the air and not us? But now, let me tell you a story. The legends, the legends of Daedalus. Many years ago, Daedalus and his son Icarus were trapped on an island. They were disheartened as they won't be able to go back home. They were lying on the sand in the sea, near the sea, and Daedalus saw a bird flying over him. He could have thought, if bird can fly, why can't we? And quickly he went up to the jungle and collected every feathers and wax things to stick them to their arms. And Daedalus knew that if they go up in the high in the sky, the heat of the sun the heat would sky too high when the heat wax would melt. He warned his son that the air idea actually worked. They were flying like birds. Whoa, sounds amazing. Icarus got excited and went high and high. As a result, due to the heat of the sun wax, his his feathers he fall down. His feathers, his wax all melted down now. But the idea but the idea of them actually worked. And now what do we learn from the story? Hmm. Now the moral of the story is we should learn to the elders. We should listen to the elders as they always say for our best. And the thing is, humans also dream of flying like ancient humans imagined of flying. Even humans can fly, but we don't know if the story is true or not. Now, here comes the another story. Da Vinci flying machine. Okay, Da Vinci was a famous painter, sculptor, and whatnot. He was all in one. He was all rounder. After getting inspired, I don't know whether it was true or not, but after getting listened to the story, he Daedalus, many people inspired to fly and imagine that they can fly. Thought of flying, he also thought of flying, and he was one of them to get inspired from the story of Daedalus. It gave wings to the people to fly up in the air. He made this sketch to make people fly with flapping mechanism, but he can succeed too. Many design came later. You all must be knowing about skylight lanterns we fly in the air. They work on the principle of hot air balloons. There's a story behind that. There were two brothers. They were called as Fontagolfis. They used to stay in Paris, and in 1983, oops, my bad, and they demonstrated the hot air balloons and kept a rooster, a duck, and a sheep into it to demonstrate the hot flying air in the air. In the air. Okay, now what do we learn from this? We should not use animals for our own demonstration. We should not do that. We should not trouble the animals for our own good. Story of these two gentlemen were also made attempts in making aircraft after getting inspiration from the past events and tried to make a design and fly an aircraft. These were Wright brothers. They made a design and they were able to fly. Don't know how to land, but in 1903 they found a way to land it. Now we must now we'll look at this video and we see how they actually work.
Whoa, Wright brothers have put in too much effort at the very beginning of 20th century to create the first powered flight. Look at their efforts. How beautiful the aeroplane is. It is very quite different from the aeroplanes that we have today. It has two wing structures, one at the top and the other at the bottom. This structure is what we call as biplane aeroplanes.
Okay. So, but after that, they were able to figure out how to land an aircraft and they succeeded. And here comes the first powered aircraft. When there's a will, there's a way. You should never give up. Like Wright brothers, you should always keep trying because practice makes a man perfect. Now, after so many attempts, people, now Tejas will tell you what forces acts upon a plane, and stage is all yours, Tejas.
Thank you, Aakansha, for that wonderful narration of the history of how aeroplanes were created. Well, hot air balloons were created in the year 1783 by the Montgolfier brothers. However, the hot air balloon design worked on the principle of buoyancy. That is, the hot air is less denser than the air surrounding it. You know that when you place something which is less denser than water, it will float above water, right? Something like a wooden plank. A similar principle is used in hot air balloons to make the balloons go up. Isn't it interesting? Well, the same principles work also for an aircraft, but here we call them as the four forces of flight. Let's learn about the four forces of light that act upon an aeroplane. First, we have the lift. Lift is the one that keeps the aircraft in air. Next, we have weight. Weight will be in the downward direction. And the third force is called as the thrust, which is in the forward direction, and drag, which is in the backward direction of the flight of an aeroplane. We'll learn about these forces in detail in the coming slides. What is lift? Consider this aircraft. If this aircraft were to remain in flight, there must be some force which will be keeping this aircraft in air, right? The force that lifts this aircraft up in the air is what we call as lift force. It acts in the upward direction, lifting the aircraft. This is something similar to like helium balloons. When you have a bunch of helium balloons, those balloons try to exert a force in the upward direction, right? A similar kind of force is what acts upon an aircraft and keeps it in the air. The second force on acting upon an aircraft is the weight of the aircraft. It is the same force that gets you back to the ground when you jump up high. Consider this aircraft. If I leave this aircraft right now, it fell down. Why did it fall so? It is because of the gravitational pull of the earth. Earth exerts a pull upon all the objects that are on its surface, like a phone or a piece of paper or anything. All objects are being pulled down by earth. The force that is the reason which pulls down the object to earth is what we call as gravity. And due to gravity, we have the weight force which causes the aircraft to come down. Let's look into the third force acting upon the aircraft. Well, as you see on the screen, an aircraft will be going in the forward direction. The force that is responsible for making the aircraft go in the forward direction is what we call as thrust. Thrust is responsible for the forward motion of the aircraft. Okay, what is the fourth force then? Well, when we have thrust, there must be some opposing force that must restrict thrust. So that force is what we call as drag. Drag is the force which slows down the aircraft in the direction of its motion. Let's say the aircraft is going in this direction, then drag will act in the opposite direction, preventing the aircraft from going forward. It is similar to the person walking on the screen against the direction of wind. When you're trying to move against the direction of the wind, you will be facing what is called as resistance. You will find it very difficult to go forward. The force that makes it very difficult to go forward or that prevents you from going forward is what we call as drag. Now that we know about the four forces of flight, let's understand these four forces of flight through a video by Thinking Captain addressing how do planes fly. Thank you, Thinking Captain, for explaining us on how do airplanes fly. Well, Thinking Captain was talking about shapes affecting drag. Let's see how shapes affect drag. Consider this particular pad. This piece of cardboard, when I have this and when I try moving it in the flat face ahead, I feel that there is some air resistance that is preventing this part from moving forward and backward. So that resistance is what we call as drag. However, the drag force which resists the objects from going forward is not the same for all shapes. We find the highest resistance when it comes to something like a flat face. But when it comes to a spear will experience a lesser drag force because it allows the air to be curved, take a curved path and minimizes the drag. Okay, Tejas, you're talking about plate being held flat. What if I hold the pad in the flat position and try moving like this? Yes, you got it right. When you have it in a very flat position, that is in the horizontal position, and when you try moving it like this, that is cutting through the air, you'll find that you'll have the least resistance while moving this. However, when you try moving this particular pad uh, in the face first direction, you'll find very high resistance coming into picture. You can feel the resistance when you try moving the pad, but you'll feel less resistance when you have the pad being faced flat down. This concept is used, and this particular flat shape combined with the shape of the spear at the front is what we call as a streamlined shape or the airfoil shape. This shape is used in wings to minimize the effect of drags, to minimize the resistance faced by an aircraft while it's flying. Whoa, that is amazing. Let's learn more about how wings generate lift. Aakansha will explain you on how wings will be able to generate lift. Aakansha, can you please come on the screen and tell us how wings generate lift?
Yes, Tejas, I can. So, you have learned a lot about forces of airplanes like drag, thrust, gravity, and lift. Now, you must be thinking, how does wings produce the lift? When we talk about the wings, we have them in streamlined shape, like as shown in the previous slide. Let's suppose this is a plane. Now, when it flows through the air, we have the air coming at the top of it and at the bottom of it. Now, when the air goes through the wings, it creates a low pressure at the top, and high pressure at the bottom of it, because the air moving under it, below it, it's slower in is slow at in speed and velocity, and the air moving and the air moving above it is in higher. So when the pressure at the bottom of this wing is greater and the pressure at the top is lower, that's why it produces a lift in this direction. Now, Tejas, have you got it?
Yes, Akansha,
So
thank
the
you for
wings,
letting me
so the
know.
wings, so the wings produce a lift. That's why the airplanes fly in the air like this. Now, classification of aircrafts. We have lighter than air aircraft and we have heavier than air aircrafts. In lighter than air aircrafts, we have air balloons and airships. They were used in ancient time, and the heavier than air aircrafts are further subdivided into two parts. That is power driven, and the other was is non-power driven. Non-power driven are contain gliders and paragliders. You must have seen them in mountain area, like people paragliding through the mountains and beaches and all these things. And power driven aircrafts have engine in it, like a rotorcraft or an helicopter, and the other one is aeroplanes. Now, the Tejas, the stage is all yours. Now, next you will present what to learn, what you are going to say. Then the parts of the airplane.
Thank you, Akansha, for telling us how the wings of an aircraft produce lift. I didn't know that it was due to the pressure difference. That is, there will be more force which will be exerted in the upward direction and less force in the downward direction, which causes the wing to go up. Thank you for teaching me that, Akansha. I learned a lot from you. Now, let's go to the parts of an airplane. Just like we having humans having many body parts, aircraft also has different body parts. First, let's talk about the main part, that is the fuselage. This section that you are seeing right now on the screen, that is from the nose to the tail, this huge tube-like structure is what we call as the fuselage. This fuselage is a cylinder-like structure wherein we have cockpit at this in the front. The cockpit region is the region where the pilot of the aircraft is seated and he controls the aircraft. Then at the back and in the middle, we have what is called as the cabin. Cabin is the place where we all sit. The passengers are seated in the cabin region of the aircraft. Then we have the two wings of the aircraft. A pair of wings is what makes an aircraft the best to fly. And the in the rear end of the aircraft, we find that this region is called as the tail section. We have a vertical tail. This vertical tail or the vertical stabilizer, it is also called as the fin. It is the fin of the aircraft. Then we have a horizontal stabilizer, that is a horizontal small wing like structure, which is called a tail plane. And at the end of these tail planes, we have a small flap called as elevators, which are used to control the movements of an aircraft. Again, and on the fin, we also have a flap here, which is called as rudder to control the direction of an aircraft. At the tips of the wings, we have what are called as ailerons. These are also used to control the movements of an aircraft. Then again, how can we forget the engines that move the aircraft forward? Usually, the engines on an aeroplane are mounted below the wings. We'll have engines mounted below the wing region of the aircraft. These are the major parts of an airplane. Okay, you all must be wondering, how do aircrafts go forward? I invite Akansha again on screen to tell us more about how aeroplanes go forward and what is propulsion. Akansha, can you please come on screen and tell us more about what is propulsion? Okay, I guess Akansha seems to be lost. She must be busy in another work making her own aircraft. She'll join us later. I'll go ahead and tell you what is propulsion. Well, propulsion is the act of moving or pushing an object in the forward direction. How do we do it, and what is does that mean that if I move an object forward, let's say a phone or a paper or a ball in the forward direction, is that propulsion? Well, yes, technically yes. Anything that you move forward or you push forward is what is called as propelling. The In the figure you see that a person is trying to row a boat, and again in the figure you see another kid is trying to swim in a swimming pool. Both of these acts are called as propelling acts. Well, how do propulsion work? From rowing a boat to firing a rocket, all these acts are nothing but propelling. They work on what is called as Newton's third law of motion. Newton's third law of motion states that for every action, there is an equal and opposite reaction. What do we mean by that? In When we consider an aircraft, we see that the engines emit gas in the backward direction. So that is what we call as the action. So when we have an action in one direction, there will be a reaction, that is equal and opposite force generated in the opposite directions. As the gas is being ejected in the backward direction, we have the rocket moving in the forward direction. This is what Newton's third law of motion states. Well, you all must have used a balloon, right? While blowing a balloon, if you accidentally happen to release the balloon goes all over the place. This also is an act of propulsion, and it is caused by Newton's third law of motion. Hope you learned about propulsion. Now, moving on to aircraft engines. Well, aircraft engines are the ones that are used to propel the aircraft forward. Just like a balloon ejecting gas out in the backward direction, we have engines sucking in air from the front and burning them and ejecting them at high velocity in the backward direction so that the aircraft can move forward. There are different types of engines, but the most common one and the most famous one that we all know is are the jet engines. As you can see in the diagram, the air that is when an aircraft is moving in the forward direction, the engine will be mounted below the wing. Air will come into the engine here, and it will be burned inside a combustion chamber, and a high velocity air will be ejected in the backward direction. The air will be moving at so high speed that it propels the aircraft in the forward direction. Now that we know how an aircraft engine works, let's also learn how to control an aircraft. Well, most of you would be aspiring to become pilots, right? Most of you would have dreamed to control an aircraft and to fly high up in the air. I'll tell you how to control an aircraft using three control surfaces that is most common in all the airplanes. There are three different controls that are possible in an aircraft. One is the pitch control, that is nose up moment or nose down moment. Whenever the nose of the aircraft goes up, we call it as pitch up or the nose up moment. If the nose of the aircraft is down, if it pitches down, we call it as the pitch down moment or the nose down moment. We require nose up and nose down moment during takeoff of an aircraft and during the landing of an aircraft. How do we control the nose up and nose down of the aircraft? This is controlled by what are called as the elevators. By making use of elevators that is located at the back of the aircraft, we'll be able to pitch up the aircraft and pitch down the aircraft. If the pilot wants to pitch up the aircraft, the he pulls out a stick. He has a pitch up and pitch down control stick here. He pulls down the stick back so that the aircraft pitches up. And if he wants to pitch down the aircraft, he pushes this control stick down so that the aircraft pitches down. Next, we have what is called as the roll control. to demonstrate roll control, you all must have used a cycle, right? You all would have ridden a bicycle. In that, you have what is called as the steering handle. Similarly, pilots also have something called as the steering handle. Using the steering handle, what the pilot does is that if he wants to roll towards the left, he rolls the steering handle of the aircraft towards the left, and if he wants the aircraft to roll towards the right, he moves the steering handle of the aircraft towards the right. On moving these steering handles towards left and right, the aileron flaps that are located at the edge of these wings are moved up and down so that the lift force acting on one of the wings will be more than the other one. This causes the aircraft to rotate. So if I apply more force here and less force here, it means that the aircraft will move towards left. It will roll towards left. And if the force is more here, the left force is more here, and the left force is less on the right wing, the aircraft will roll towards right. This is how a pilot controls the roll motion of an aircraft. Next, we have what is called as the direction control. Just like in a bicycle steering, we control whether we want to go towards the left or towards the right. We have the direction control of an aircraft being done by the rudder flap located on the fin of the aircraft. The rudder, if the pilot wants to deflect the aircraft towards the left, he deflects the rudder, which is located at the back of the aircraft, towards the left, so that there is more force produced in this direction, causing the aircraft to go towards left. Similarly, if he wants to move towards the right, if he wants the aircraft to turn towards the right, he deflects the rudder towards the right. Isn't that quite simple? Actually, not. Whenever the pilot has to control the aircraft, those controls have to be transmitted all the way back to all these control surfaces, which requires many complex mechanisms to be housed on the aircraft. Though it looks very simple to control an aircraft, we require much more knowledge as to how much steering has to be put in so that the aircraft we will be able to handle the aircraft in a better way. Now that we know about how to control an aircraft, let's learn about the shapes of the wings that we have on aircraft. First, we have what is called as a rectangular shaped wing. These rectangular shaped wings were used in earlier planes. The airplane that you saw, which the Wright brothers were using, is makes use of the rectangular wing. However, the rectangular wing structure poses more drag when it comes to high speed. Why is that so? Try doing this exercise. Stand up in the place wherever you are and stretch your hands out and try moving forward. You will feel that you find more resistance when you have your hands stretched out like this and when you start trying to run. However, when you're stretching out your hands, when you start trying to run, you automatically find that your hands go backward. That is, they sweep towards the back. So this very same concept was employed in the aircraft so that the aircraft experiences very minimum drag. So we have what are called as swept back wings. Then we have what are called as triangular wings in order to achieve a very high speed. How did we learn about all these things? All these concepts were actually learned from nature. When you look at how birds fly in the sky, they always fly in the V pattern. They even during when they dive down, they make sure that their wings are located back in a triangular shape. That is to minimize the drag that they experience while they're diving down. So we learn from nature, we learn from birds how to minimize drag. We learn from birds how to fly. Isn't that amazing? Now, based on where the location of the wing is with respect to the body of the aircraft, there are three classifications again. If the wing is located above the fuselage of the aircraft, we call it as high wing. If the wings are located in the middle region of the aircraft, we call it as mid wing. And if the wings are located at the bottom of the aircraft, we call it as low wing. Oh, here we hit a pause point. What is the pause point? How does the shape and position of wings affect aircraft performance? It's time to think. Can we learn about this by doing an activity? I call upon Aakansha on the screen along with me to make a paper plane so that we'll be able to learn about how wing shape affects the flight of an aircraft. I request you all to grab a sheet of paper next to you or ask anyone to help you out to get a sheet of paper. Make sure that you use a waste sheet of paper and not a white sheet of paper, because we are not it is not good to waste an unused sheet of paper. I have with me a used sheet of paper right now, and Akanksha also has a sheet of paper. I hope you all have a sheet of paper with you now so that we can make paper planes. Okay, we are good to go. Now, I have a sheet of paper. Akanksha, follow the instruction that I'm giving to you. Okay. What we will do is that we will fold this paper such that such that we get a center crease here on the aircraft. We'll be folding this paper into half. That was easy. Now that we are done folding the paper into the center crease, what we will do is that we'll take this corner of the aircraft and we'll fold it towards the center crease and in the form of a triangle. Then again, I'll repeat the same step for the other corner too. You'll get a structure something like this. Hope you all have followed the steps up till now. Now, we will go a step further and will again fold this entire line crease touching towards the center of the paper plane. Something like this. Can you see that? This region, this crease touches the center crease now, and it is being folded again to increase the angle of sweepness of the aircraft. I'll repeat the same procedure for the other side of the paper plane. Now that it's folded, I'll fold it in half again. You will have a structure something looking like this. Hope you all have followed the instructions up till now. Now we'll fold this region of the aircraft towards the outside to make a crease again. We'll repeat the same procedure again for the other side too.
Oh,
Whoa,
I made a
there you
paper
go.
plane by myself.
Yay. Now throw this paper plane and look how far it goes. Hope you all had fun time making the paper plane. If you want to explore more such paper planes, something like this and this and a helicopter like paper plane, do follow the website link provided at the bottom of the screen so that you'll be able to make more and more different designs of the paper plane. Now, let's go and learn something more about the aircrafts. Coming to aircrafts, the airplanes that we talk about find wide variety of applications in the modern day world. They're used as private jets, that is, business people, rich people, everyone who want to travel from one country to another have their own private flights to, and these private jets are used for comfortable journey from one country to another or from one continent to another. The most common applications that we see, the airplanes that we see in the sky every day, are the commercial airplanes. These are the airplanes that support passengers like us to, to commute from one place to another. There are three types of commercial passenger airplanes. One is the jumbo passenger airplanes. These airplanes are very, very, very huge. They carry somewhere close to 700 to 800 people on board at a single go. Isn't that amazing? Next, we have the mid-size passenger airplanes. In mid-size passenger airplanes, they support somewhere close to 300 to 400 passengers at a single go. Then we have light passenger airplanes wherein somewhere close to 100 people can travel at the same time. If you have ever wondered how such big goods, how do we transport very big equipments from one country to another, then the answer is cargo planes. In cargo planes, we'll ship huge cargos, huge materials that has to be transported from one country to another. Well, the image that is being displayed on the screen is what is called as a beluga aircraft by Airbus. This beluga, the design of this beluga aircraft was inspired by a beluga whale. Isn't that amazing? An aircraft that looks like a whale. Coming to military applications, these aircrafts are also used in military forces to launch an attack on the enemies. They're used to bomb the enemy camps. They're used to do missile launches from air to another aircraft. They're used for a wide variety of applications when it comes to military applications. You all would have seen a remotely controlled drone, right? Drones are have been the most common kind of aircraft that we see around every day in our day-to-day lives now. They have become a part and parcel of our day-to-day lives. They find a wide variety of applications. These drone vehicles that we control using a remote are used to spray pesticides over a very large agricultural field, or they are also used to take photographs from a very top height, very high region, so that we'll be able to cover a large region in a single photograph. They're also used for surveillance. That is, whenever we have a large crowd, if we have to monitor them, if we have to check what's happening somewhere or something, they're also used to look after a particular region. Well, UAVs are finding a wide variety of applications in current days. We are also looking for a solar powered aircraft. In solar powered aircrafts, the aircraft is being powered by the energy from the sun. The wings of the aircraft are embedded with the solar panels so that the electricity generated from the solar panels is used to propel the aircraft forward. Isn't that cool? Okay, you all must be wondering, why do all aircrafts look alike? That is, they all have a similar structure, something like this. But there are also few unusual aircrafts that differ in their design. We have many aircrafts that are nothing but a large wing-like structure. There are also aircrafts that don't have wings at all. And there are also aircrafts, instead of having a backward sweep, the wings have been forward swept. That is, they fly with their wings being swept in the forward direction. When it comes to aircraft, we always believe that the aircraft is symmetric. That is, this side is similar to this side. Well, that is not the case in most of the aircraft. There are also aircrafts that are not symmetric. That is, uh, on this side they have a different structure and on the other side they have a very different structures. So aircrafts can be of any kinds, any shape, as long as they fly, they're still called aircrafts. Hope you all enjoyed the session today and learned about how do aircrafts fly. If you have any questions, do post it in the chat section so that we'll be able to answer all your questions. I invite Aakansha on screen now along with me to join and demonstrate how to submit your assignments. The assignment for today is that you have to draw the picture of an aircraft and label different parts of the aircraft like engines of the aircraft, wings of the aircraft, cockpit, tail, elevators, rudders. And after you're done marking all these parts, you are also expected to mark the four forces of flight, that is lift, drag, thrust, and weight. Once you are done drawing the picture of the aircraft with all its parts mentioned, take a picture of that sketch and do send us a PDF in the way that I'm going to show you right now. I
Tejas, do we
have a
have to
fun.
make paper planes also and send them as a homework?
The paper planes are not required for the homework, but it can be used for fun activity. I have an assignment with me right now, which
Okay.
I'll be submitting on using the Google Drive. The file that contains the image has to be uploaded to the Google Drive. Once we are done uploading the file to the Google Drive, we have to right click on the file and select what is called as Get Shareable Link. Once we select that icon, there pops up a menu which says that this link is restricted. Change that to from restricted to anyone with the link can access the given folder. Once you select anyone with the link option, copy the link and go to the site where the classes are being conducted. Now, as we are in the kids section, let's go to the kids section and select submit homework. We'll find that for day 4, we have day 4 homework, we have submit homework option here. Let's select that submit homework option. Now, once we select that option, it will redirect us into a Google form. In the Google form, first we are supposed to fill our name, then we are supposed to fill our email ID, then the day that we answered, and if we have any messages to be sent into the teachers, or if you loved any particular part of the video, do mention that in the message. Then here in the link to work part, paste the link of the file that you are sharing. Once you are done pasting the link, select the submit options. Once you select the submit option, you will be done submitting your homework. And that is all.
Okay, Tejas. Now the kids must understand what how to submit their homework.
Why there is a question that about why can't gravity pull aeroplane and birds down? Well, actually, gravity pulls everything down. It pulls both aircraft and a phone and a bird and also astronauts down too. But the thing is that the lift force that is lifting the aircraft will be much more than the weight that is pulling it down. When the lift force is more than the weight that is pulling it down, it will cause the aircraft to go up. It is similar to the tug of war game that we all play. If one person pulls harder than the other person, then the thing goes in the direction of in the direction where the pull is the most. Similarly, the lift as the lift force is the highest, we have aircraft going up and not coming down. Once the lift that is being generated by the aircraft is reduced, we'll have the aircraft going down gradually. Let's look at some other questions that we have. Why do birds fly in V shape? That is an interesting question. Well, birds fly in V shape because, as I told you earlier, when you try to run with your hands stretched straight flat, you find that it is very difficult to run with a straight arm. Whereas if you bend your hands, that is towards the back, making it into a V shape, you'll be finding it easier to run. The same concept is applied by birds. That is, the bird at the front will cut through the air so that the air is split, and with the resistance is minimized for other birds to fly in. So when we have the V shape kind of thing, the drag force faced by the aircraft is minimized. How does a helicopter fly? Helicopter flies similar to that of an aircraft, that of an aeroplane, but it flies with what are called as rotating wings. Uh, in aircraft, we have what are called as fixed wings that generate the lift. However, in a helicopter, the wings that are rotating on the top of the aircraft produce the lift that is required to take the aircraft up. Cost depends upon the type of aircraft. Yes, not all aircrafts cost the same. The cost of manufacturing a particular kind of aircraft differs from what kind of engines we use, how many passengers it has to carry, how long it has to travel, what kind of materials are used in the aircraft. So cost varies from one aircraft to another. Fuel used for an aircraft. Most commonly, we use what is called as the white kerosene fuel to run the aircrafts. There are some composition of these fuels, that special fuels that are used to increase the efficiency of an aircraft. These are set by the aviation agencies that govern the flying of these aircrafts. How to make wooden plane? Okay, that is an interesting question. The wooden plane that you are looking at right now is a model plane. These planes are made by what are called as balsa woods. Balsa woods are very light in nature, so they help the wooden planes to fly with ease. These balsa woods are easy to cut using a cutter, like a cutting knife. We get these balsa woods in the market. When you They come in different thicknesses. You can Google about balsa wood gliders on Google, and you'll be able to get instructions on how to make wooden planes that you see something like this right now on the screen. What other questions do we have in the chat section? Uh, let's look. How can the airplane fly and we can't fly? We sit in airplane. Ha, that is an interesting question. Well, the question says that how can aircraft fly and we can't fly, but we when we sit in the aircraft we will be able to fly. The answer is very simple. We won't be able to generate the lift force that lifts us up in the air, but an aircraft can generate the lift force that lifts the entire body of the aircraft. So when the aircraft is being lifted, anything that is placed on the aircraft is also being lifted. That is how when we are seated in the aircraft, we will be able to fly, and when we are seated on a normal chair, we can't. Hope someday, if you watch Doraemon, if something like a bamboo copter if someone invents a bamboo copter, hope that we might be able to fly with at the very place that we are being seated. Do all planes fly with engine? Yeah, Aakansha had already spoken to you about different types of airplanes, right? We have what are called as powered aeroplanes and another class of airplanes called as non-powered aeroplanes. In non-powered aeroplanes, there won't be any engines. They are much similar to gliders. That is, these aircrafts are uh, ridden by a single person. He holds a glider, something like this, like a huge wing-like structure. He or she would go to a very high altitude. From there, they dive in so that they will be able to fly from the velocity that they gain, the speed that they gain while they're jumping off. That is how they fly without an engine. How do aeroplanes manage to cut through clouds and fly on top of them? Wow, that is an interesting question. Well, aeroplanes can cut through clouds because clouds are nothing but gases. If you have ever seen smoke, if you place your hand through it, you'll be able to cut through smokes, right? So clouds are nothing but water vapors that are formed in the sky. So aircraft being a solid material and having a forward velocity, it will be able to cut through the clouds because of its forward motion, and it stays up above the clouds because of the lift that is taking it up. The lift force keeps it up in the air, and the forward thrust force is what helps an aircraft to move past the clouds. Why do aeroplanes need wings? Well, the reason why aeroplanes need wings is that the wings are the ones that produce the lift force that is required to lift the aircraft to go up. Without the wings, the aircraft cannot fly. However, there are some designs wherein just the body of the aircraft, that is not having the wings, and just the fuselage is used to produce the lift. The unusual In one of the unusual aircraft that I showed you, the second unusual aircraft did not have any wings, but still using the body of the aircraft, something like let's say this bottle. If this bottle were able to generate the lift required to go up, then there is no need for having wings for the aircraft. But however, most of the designs don't are complex to generate. Most of the designs, they find it very hard to generate lift without without wings. Why some aircraft have fan on their nose? Those are not fans, they are called as propellers. So aircrafts that have propellers are used to suck the air in the front and push them towards the back. uh, as we told you in propulsion, as it was explained in propulsion, we find that we in order for us to go front, something has to be pushed back, so that Newton's third law comes into play. In order to do that, the propeller which is placed at the front of the aircraft, the fan like structure that you're talking about, the propellers, they suck the air in, they push it back so that the aircraft goes front. Do we have brakes and aircrafts like in cars to stop? Yes, definitely yes. Aeroplanes also do have brakes, but brakes are not to slow down the aircraft in air. In air, we have something called as the uh, slats that come up on the wings, that increase the drag of the aircraft. That is, if we increase the drag, that is the resisting force which prevents the aircraft from going forward, we will be able to reduce the speed of the aircraft in air. So we use what are called as slats on the wings to increase the drag, to minimize the speed of the aircraft. When it comes to landing, that is when an aircraft is about to land, uh, the landing gears have uh, they come and they try to slow down the speed of the aircraft by something called as air brakes. How to make a wooden aircraft? As I told you, they are made by what are called as balsa wood material. Type in Google, or else we will share in the resource materials as to how to make wooden aircraft in the resource section. Do check out the resource section wherein we will be uploading the presentations that we have used during the classes, and also the resource materials that you can use to learn more about aircrafts. And we will be sharing a link about how to make a wooden aircraft in the resource section. Do check it out. Okay, that was for the question and answer session. I hope all the questions have been answered, and I hope you all are clear on how to submit your assignments. And if you do have any queries, do post it in the chat section. We'll be more than happy to answer. I hope you all learned about how aircrafts fly today, and hope you all are excited about tomorrow's class and how astronauts float in sky, or float in space. It is all about weightlessness. See you all tomorrow at the same time at 7 o'clock. Stay tuned in, and do like, share, and send in these links to all your friends. Ask them to watch these channels. Bye for now. This is Tejas KV along with Akansha signing off for the day. Bye bye.